Hey, Antikythera crowd. This is James, and Mark is behind the camera, and we're going to start talking some more about our Antikythera. Now, I got good old number 13 here. This is what I'm talking about when I say Antikythera, is the Antikythera mechanism, and 13 still works, and he's there. And I was going to talk about how to use them and stuff, but I decided to make a departure, and we're going to talk about the journey about how number 13 and all the other S&T Geotronics Antikytheras came about. Now, we had a backer for one of our other projects that wanted an Antikythera, and so we started working on the deal about 3 years ago. And we started designing gears, lots and lots of gears. And this here is what I call a rotating assembly. It's basically the aura, or the unit that shows where the planets and all that are, and drives the rest of it through this gear here I call a link connector. But anyways, we're going to talk about how I got to this point and start sharing a little bit about that journey, because we're actually starting to make one that's going to be made out of metal. The original one was made out of bronze, and we're probably not going to use bronze. We'll probably use brass that is zinc and copper instead of bronze, which is tin and copper, because zinc and copper is way easier to machine. And so to get ready, I'm tooling up to make one out of aluminum. This is the iconic gear that I produced. It's a prototype metal iconic gear. It was made over there on Charlie the Wooden Robot. Give them a view of Charlie the Wooden Robot, which is a machine that was made just for the purpose of making the metal unit. And here is the sun axle lever. This is the sun axle right here that holds the hand out here that points where the sun is. It's not completely finished, and this is a prototype one. The axle lever was made by the robot, and the axle itself I made on the lathe right here, and put the hole in the middle of it for the moon shaft to go through, and made it where it presses into the lever where it'll never move again, and machined it all, and it works really good, and that's a nice one. But this little rod here started out like that, and to get it down to here, it produced this much waste, which is kind of unacceptable. So we're going to go through and we're going to redesign this to start out with a slightly smaller rod that will require less lathe time. So this is the rod that I cut a piece of off to make that sun axle and turned down so small, and it starts out at 15, well, it's 16 millimeters basically, and I turn it all the way down to 5 when I can start off with this one here that's 12, or perhaps even get one that's 10. But I'm going to have to go and redesign the lever a little bit to accept this piece of metal, and I'll show you how that's done. We go over to the CAD machine, and we start by manipulating our drawing a little bit. Alright, so let's open up the file that made that on the CAD program. And I'm going to drag him over to this monitor where it's easier probably for the camera to see. And the problem is this circle right here has a diameter of 14, and that is too big for the smaller rod. So the smaller aluminum rod that I have is 12.75, which is, it's actually probably an English rod, but I just can't stand doing anything in English, so I'm going to go right here I'm going to change this 14 to a 12. Enter and press enter, and then my circle got smaller, and now I have a 12 millimeter hole instead of a 14 millimeter hole in my axle rod lever. And that's going to allow me to use the smaller rod and not quite have so many chips end up in my bag. So I'm going to save this file. I'm going to just click save, and yep, Sun axle rod draw lever, save, and I'm going to replace it, and then I'm going to file, save as a DXF so that Charlie the wooden robot can understand how to use it. I'm going to click save again and save the DXF. Yes, we're going to replace it. Alrighty then, and now I'm going to prepare Charlie to make this new piece for me, and we'll get him started on making the new piece, and I'll see you in just a sec. Alrighty, now we're going to use the other computer that's running the Linux that has the GFX to G-code converter program on it, and we're running Debian 11, or no, Debian 12, and I'm going to go and I'm going to open my DXF to G-code program, maybe, if I'm lucky. Is my machine running? Open. Come on, old machine. And then we're going to go and we're going to grab our file, open, Sun rod lever DXF. And no, don't update your software, just open the file. And there's our file. And I'm going to go to options. I want to turn him around, options. And I want to rotate all, and I want to rotate it 180 degrees. And now I'm going to move my workplace 0 once I get the right menu. Move workplace 0, and I'm going to say auto, and then he's going to move the workplace 0 right there. And now we're going to go through and we're going to figure out how we're going to do this and make our jobs. So I want to go, let's see what we're not going to do that one right now. We're not going to do that one right now, so I'm going to disable those two. And so we want this one, and we're going to use a 2 millimeter end mill. So I'm going to find out which one my 2 millimeter end mill is, maybe. Alright, there's my 2 millimeter end mill, 2.20 tool 3. I'm going to close this, and I'm going to say that I want tool 3, and the retraction area is going to be 5, and the safety margin is 3, and we're going to start at the top of our workpiece, and we're going to go 0.12 per pass, and the final mill depth, and we're going to go 400 miles an hour, and the feed rate for Z is fine. And then I'm going to go over here, and I'm going to cutter compensate to the right, and then you can see this little thing is our tool path, and it's going to cut this inside hole out for us. And then we're going to go over to this one, and I'm going to do this one a little differently. I'm going to tell him to just drill a hole for me. I'm going to say drill the bore, boink, and he's going to drill a hole that big right there, just big enough to put a screw in to hold our centerpiece down. And since he's drilling, we're going to go in here and we're going to say the retraction area is 5, safety margin is 3. We're going to start at the top of the workpiece with 0. The final infeed depth, we're going to go 0.12 and 4.5 and 400 and tab, and there we go. And now I'm going to export this as a job, and I'm going to call it 1 STP, first step, and I'm going to save the file. Point. There we go. And now we're going to go back and do this for the other two. We'll enable this one, disable that one, and disable that one. And these two here, I'm going to adjust these together. 5, 3, 0. One, 2, minus 4.5, speed of 420, that's good. Really? 5, 3, 0, infeed depth, 1, 2, tab, 400, tab. Alright, and now we're going to set the cutter compensation to left compensation, and you'll see it draws on the outside of it now because the tool's actually going to go outside of it. And then we'll go to this one here and we'll go cutter compensation, and I'm going to say right compensation, and now he's going to cut on the inside of that to where our hole will be 12. And now I'm going to go ahead and export, optimize paths and export, and this will be 2 STP, second step, and save. And now I'm done with this part of the program, and so I'm going to go ahead and eject my flash drive. Eject, and it's safe to remove it. I'm going to remove it, and I'll see you at the machine that's going to do the work. So now I'm at my other Linux machine that has the universal G-code sender that is actually going to control the robot here. And we're going to wake the robot up. He's turned on, and now I'm going to connect the robot to the machine. And he says connecting, hello, okay, alarm. Yep, he always wakes up in an alarm. We're going to unlock him, and I am going to send him home because there's no telling where he's at. And so the machine will home now. He's going to pick his Z-axis up. Sorry, Z-axis isn't very fast. And he's going to hit the limit switch. In a minute, there he did. And then he's going to try it again to make sure it's exactly where he thinks he is. And then he's going to do X and Y. And he'll hit that limit switch, click, and then he'll try them both again. And now I'm going to set a new 0. I'm going to tell him to go to his old 0 because it's not that far from where I'm going. And then I'm going to go to jogging my controller. I'm going to go X plus. I'm going to run my X-axis over to my dot, pretty close. And then I'm going to Y plus. I'm sure that's my dot. Oh yeah, that's my dot. Right there. Y plus. So now I'm going to say I want to do 1 millimeter at a time. I'm going to go Y minus. And X minus. And that's where I want to be. And now I'm going to take and bring it right over here. And that's where I'm going to zero him. And I'm going to say 0 and 0. And there's my workpiece 0. Now I'm going to go get step 1. Open. And small gears. Let's go to Antikythera metal, axle rod levers. And sun gear, axle rod lever. First step. Open. And you're going to see the 2 holes that he's going to do on the screen. And then I'm going to start my spindle running. I'm going to start the vacuum running. And then I'm going to push play. And Charlie the wooden robot is in action. He's fixing to cut metal. Here he goes. Alrighty, he's done making the slot, and now he's going to go over and drill that hole for me to put my screw in to hold him down. There he goes, and now he's going to drill. Drill, baby, drill, baby, drill. Here he goes. Alrighty, Charlie here is just now finishing up this hole that he was drilling for us. He's got about 1 or 2 more plunges to go. He goes down and he drills a little bit and he pulls it out and lets the bit get done, and now he's going to go to 0 position, and then we'll run it out and we'll put some hold down screws in there. Alright, and he's done. Now we're going to set Charlie up for the second job of this. We've got to move our part out and put some hold down screws in. So he's done, and now I'm going to take it, I'm going to Y plus him out, which is going to bring the Y out to me. And I'm going to do it 5 millimeters at a time, or maybe 10. 10 is faster. Alright, so I'm going to say Y plus. Now I'm 10 millimeters out. Now I'm going to go grab me some screws out of my little box of accessories. Grab me a couple of screws out of here. Now I'm going to put a screw right here in this hole that he drilled for me. The whole purpose of this is to anchor that centerpiece down where it doesn't move around and break my bit. And then we'll put a couple screws in this to hold this down for us. Nice and secure. And one more screw. If I can get it. Big screw, little screw. I'll put one more screw right here. Make sure everybody's good and snug. And now I'm going to go back here to my toolbox and I'm going to tell him to return to 0. And he's going to go right back where he started from. And now I'll grab my other file on the computer. There he goes. And he's back at 0. So let's go File, Open, and we'll get our second step. Open, and there's our second step on the thing. We'll start our spindle motor back to running. I've got to integrate that into the controller so I can start and stop it automatically. Start the vacuum. Filler's running. And now I'm going to say play. And here he goes. He's going to execute the second step of making our sun axle rod lever. And he's going to cut that hole first. I should have made him cut the outside first, but c'est la vie. Drilling that hole, that 12mm hole, and now he's going to cut the rod out. And there he goes. We'll be done with this in just a few minutes. And we'll have our new prototype sun axle rod lever done. And this has to be done for every piece, for the whole rotating assembly and the whole back. To make one out of metal. Eventually we're going to replace the aluminum with brass. He continues to go. He's getting almost done. We'll visit him in just a minute when he is a little closer. Alright, he's almost done. He's fixing to be done. And one more little crack. And he's through the metal and just milling on the waste board. So I'm going to go ahead and stop him. Send him back to 0, and then we'll recover our piece in just a second. When he gets to 0, I'll go ahead and run the work out to us. Here we are. Go ahead and shut the vacuum off, and I'll stop the spindle motor. And here's our new lever. We'll take this piece out first. This is what Mark calls a round to it. Everybody needs to get around to it or two.
At some time.
In there pretty snug, which is odd because it went right in. And there's our round to it. It's a scrap. We'll put the screw back in the screw box and take the other two screws out of the waste board and put them in the box. And we'll recover our new Sun axle rod lever. And there she be. And then we'll see if indeed our hole is 12 millimeters like I asked for.
Dive.
So now I've got the measuring stick. And we're 11.98. That's pretty darn close to 12. So now we got this piece made, and it's 11.98. I asked for 12. 11.98 is about as close as you're going to get. And now I've got to machine this where it fits in the hole and is 5 millimeters and has a 3 millimeter hole in the middle. So tomorrow or later on we'll be cutting this off and going to the lathe and preparing our new axle. And then we have to make a jig to put the flat spots on it, and there's still a bunch to do just to make one piece.